Hi, this is Charles DiMaggio. Welcome back to R for Epidemiology. In this screencast, I want to talk a little bit about objects and what objects are. You hear a lot about object-oriented programming in computing circles, and we don't have to go into too much detail. And you could think of an object relatively naively as something that is a data structure of some kind that has attributes of some kind. In R, everything essentially is an object. Many of the things we've spoken about already are objects. Functions are objects. Vectors are objects. I'm going to talk about a couple of objects that have particular relevance for epidemiologists. So basically, you could think of objects as data structures of some kind. So there is the object itself, right? And there are a couple of objects that we should know really a little bit about. Vectors, something called a matrix, something called an array, a list, and a data frame. From the perspective of epidemiology, what I'm going to try to convince you is that a vector really corresponds to a series of observations or a series of measurements. A matrix actually can be set up to represent that classical epidemiologic tool, a 2x2 table. An array is a way to set up a series of tables, whether they be 2x2 or not 2x2, into a stratified table or a stratified analysis of some kind. A list, well, I'm going to talk about what a list actually is, but in reality, I'm going to conflate list and data frame right now, especially a data frame. A data frame essentially is a standard epidemiologic table where the rows equal observations and the columns tend to represent variables of some kind. So let's talk a little bit about some of these things. First one is a vector. A vector can be thought of as a scalar, but essentially is a series of the same thing. You could think of it like this, just a series of different things. It could be numbers, 1, 2, 3, 4, 5. It could be letters or names. It can't be a combination of the two, and we'll talk about that in a moment. A matrix is essentially a vector with instructions of some kind. Basically, a vector has a very simple instruction. It's one dimension. Goes in that dimension right there. A matrix is a two-dimensional vector, essentially. And you could think of it like this. Here is a vector, right? It's basically saying, okay, there's 1, 2, 3, 4 things. But rather than just string those 4 things along, like 1, 2, 3, 4, what I want you to do is put 2 of them into columns, 2 of them into rows. An array in R is essentially a matrix with an additional dimension. So if this then is our matrix, 2 dimensions, right? In that direction and in that direction, let's say, right? An array goes in an additional dimension, and you could think of it as going in that dimension. So you could start thinking of it, for example, as let's say this dimension here is gender. This dimension, the row dimension is gender. The column dimension, for example, might be disease, no disease, for example. And the third dimension, the stratifying dimension, could be some confounder of some kind. Up until now, the 3 objects we've spoken about, matrix, a vector, matrix, and an array, all are constrained to have the same type of elements within them. And by that, what I mean is that they must all be the same kind of data. So, for example, they all have to be all numbers, all characters, and there are a couple of other different kinds of data types in R. So, for example, they could all be logical, all logical. Let me just erase that. And there's a name for this. When everything is all the same kind, it's called atomic. And this is just vocabulary. just jargon. And those are these three things: vectors, matrices, arrays. There is, though, two other kinds of objects, one of which is a list and one of which is a data frame. But a list allows you to combine different data types. You could, for example, have one row or one column of all numbers and another row or columns of all characters. Now think about this. That actually becomes kind of important in epidemiology, right? You may have one column of your data that represents people's names or people's occupations. It's not a number of any kind. Another column of your data may be measurement of some kind. So it's important in epidemiologic terms to be able to combine different data types. Lists tend to be kind of messy, and you could think of a list as basically being like buckets full of stuff. This is what Thomas Aragon considered. So one bucket is full of all numbers, another bucket is full of all characters, another bucket is full of all truths and falses, for example. And they don't necessarily have to have any specific structure. A data frame is essentially a structured list of some kind. And a data frame really is what epidemiologists think about. And let's go on to the next one. A data frame is what epidemiologists think of when they think of data sets, essentially. It's like an epidemiologic data set. And so you have basically a nice set of data, rows and columns. Here's person 1, person 2, person 3, variable 1, variable 2, variable 3. And this is the way we tend to think of data sets. So in any event, those are the different objects. And in the next screencast, I'm just going to show you a couple of them and how they work.